Have you ever wondered about whether or not you can deploy fiber in the field? It's not that hard. Let's take a look. The common knowledge is that fiber is just too fragile to really be deployed, but that's not true anymore. Fiber cables are constructed to be installed just like category cable is for copper. So your Cat 5, Cat 6, you can pull copper the exact same way. It's got a Kevlar strength member, plenum rated jackets, and there's even options to get armored fiber cables that can be used for outdoor and direct burial applications. So what happens once you pull it? You got to terminate. But field termination of fiber is easy now. The kits and the processes have been improved significantly over the past few years, so that fiber is really the next option for the future to support all these high bandwidth applications that are coming along. Let's look a little bit at the basics of fiber construction. First, there's a core. The core is the primary light guiding structure of the fiber. There's a cladding layer around it that is actually used to do total internal reflection to keep the light within the core, and then there's a buffer, that's the protective material around the core. Why do we look at this? Well, when you terminate a fiber, you need to pull off that buffer, and you're going to cleave the fiber along the core so that you have a nice flat edge along there to do your fiber termination. There's really two different types of fiber. There's single mode or multi-mode. Single mode fiber is used for long haul networks, so if your length of fiber cable needs to be kilometers long, single mode is the way to go. It has a tiny core, about 9 microns, and it only supports one mode transmitting down that fiber. Multi-mode is used for lengths up to about 1,000 meters in length, and it's more forgiving in optical alignment because the core itself is either 50 or 62 microns. Be sure to look at your equipment though. Single mode uses single mode fiber, multi-mode optics use multi-mode fiber. You really don't mix and match the two. So what's some other terminology you're going to see when you're looking to deploy your fiber? OS1 and OS2 are single mode fiber types. OS1 is a little bit higher attenuation, a little bit shorter lengths. OS2, the newer version, lower attenuation used for longer length cables. Often single mode fiber is yellow if you're just looking at a fiber cable that's already in the wall. Multi-mode fibers are classified by OM1, OM2, OM3, OM4, and actually even OM5, which is a really new one. These are multi-mode fibers. OM1 has a 62.5 micron core. OM2 and up have a 50 micron core. We really recommend OM3 or OM4 for new products, but if you're doing a short run, OM2 is fine as well. If you're looking at fiber that's already in the wall, multi-mode fiber is usually going to be orange or aqua, but the fiber color matters to you. Here at INEOS, we actually sell a beautiful black OM4 fiber cable that's plenum rated, so you're not stuck with those bright colors. Those are really legacy holdovers from data centers so that you could just look at a fiber cable and know what it is. For AV applications, you maybe want something different. So what types of fiber cables? So now that you know you need, say, multi-mode and you've decided you want OM3, now what kind of cable do you pull? There are simplex, duplex, ribbon, and distribution fibers. Simplex is just one single run of fiber. So it's got the fiber in it. It's very easy to terminate because there's just one end on each one. Our INEOS products use simplex fiber because we only need one channel. We support both the transmit and the receive on a single channel. Duplex is also another really common fiber cable construction. Duplex is really just two simplex cables side by side so the jackets touch, but they run them as two separate fibers. This is a great option to pull if you want a redundant fiber cable. If you're already pulling a fiber cable, why not pull two of them? If you want, you can leave one dark and hook up something else optical in the future, or you have a backup in case something happens to the one fiber cable in the pulling process or the terminating process. The cost is slightly higher for duplex, but duplex is also a really common fiber cable because a lot of systems run transmit on one fiber and receive on the other fiber. Ribbon fiber cable is common in active optical cables. Ribbon fiber cables can have a bunch of fibers together, often 12 is a really common number, but you can't terminate ribbon cables in the field, so you're stuck with the length you have. Don't try to cut and terminate a ribbon fiber cable. It doesn't work. Distribution or multi-fiber cables have multi-jacketed fibers running in a single cable. These are great. Often you get a bundled construction cable that might even have some category copper cable in it, some other runs, RJ6 pulling through there. These are great for applications where you just want to pull one strand through there and have a lot of options to hook up your IP, your network, bring in some cable TV, and then your fiber solutions. Plenum versus riser is just the same as it is for copper cable. So plenum jacketed fibers meet the requirements for a plenum space. Risers meet the requirements for a riser space. What kind of jacketing do you need? There's also different options for jacketing. So standard fiber cables come in options of 0.9 millimeters, 2 millimeters, or 3 millimeters. 0.9 millimeters are tiny, tiny, tiny little cables. If you've seen our InvisiCable product here at INEOS, it looks like a fishing line. It's just a tiny, thin, nearly translucent fiber cable. They're great for applications where you want to leave them exposed, such as a fireplace or someplace that you can't punch through the wall. If you want to pull through conduit, go with a 2 or 3 millimeter jacketed fiber cable, because those let you pull a little bit harder on them and terminate them in the field. They've got the Kevlar inside them. Pre-terminated fiber cables can also be pulled through conduit using pull sock. If you need to go in a really rugged application, there's stainless steel armored fiber cables with a stainless steel tube that the fibers run inside. So those are great for short runs outside or places where you would be worried about that cable being cut. Another thing to look at for keeping your cables rugged in the environment is the boot. So there's different types of boots that you can put on a fiber cable, depending on whether you want it to be short and sleek, whether you want to put some ruggedness in it with a long wire flex or a short wire flex. So really looking at your application and what you need before you choose your fiber cable. How about fiber connectors? So now that you know what fiber cable you want, you have to figure out what type of connectors to put on that. The connectors are probably going to be one of 3 different industry standard connectors, and you just get the connector to match your equipment. So SC and LC are the 2 that are most common for field termination. SC is a little bit bigger than LC. LC is often used in data center applications, where SC we try to put in the field more often because it's a little bit bigger, a little bit easier to handle. MTP is multi-fiber connector, so you'll see this on some products, but this one cannot be terminated in the field because there's a bunch of fibers that need to be perfectly aligned and polished in machines. SC and LC have a range of termination kits available from a variety of vendors, or you can just order pre-terminated SC and LC patch cables in common lengths so that you can just pull your fiber cable already terminated and get going with fiber until you become more comfortable with the termination process. Fiber cable accessories also exist so that you can make your installation clean. You don't need to have this fiber cable hanging out the wall and figure out how to do the final integration. There's wall plates with these little standard inserts for SCs or LCs. You get your keystone and pop it right in, just like you would your HDMI or your RJ45. There's also options if you need to convert from SC to LC, for example. You just get a patch cable that's SC terminated on one end and LC terminated on the other. So there's a lot of flexibility when working with fiber. You're not locked into existing accessories. So what about termination in the field? Fiber termination really is fast and easy. It used to be that you had to mix up epoxies in the field and do these complex polishing processes. Not anymore. There's no polish, no epoxy connectors from a range of vendors. So just a few simple steps. You get the fiber connector ready and put in the little light, laser light on the end, so that you're actually going to, when you mate them together, you're just going to be able to see when the light disappears. It's not being reflected off the facet anymore. It's coupled into the fiber and you're good to go. So prepare your connector with the light, strip your jacketing and your buffer, cleave the fiber. The fiber kits will contain a little cleaver shown right here. Insert the fiber into the connector, watch when the light disappears into the fiber, and then clamp the connector and attach the fiber cable, and you're good to go. If you have any questions on fiber applications, or what to hook up to this fiber that you just installed in the wall, reach out to us at INEOS, contact INEOS.com, and we'll give you some more information on our adapter and extender products. Thank you.